So 39 degrees Celsius today, which is over 100 Fahrenheit. Just picked up a 85-liter tote and a 35-liter bucket. So I'm gonna set these up under the house and I'll show you what we're doing with this. This is the area where I'm going to be doing these experiments. A little bit of an under-house area. I've got access to a hose and we can do all of these experiments down here. But as you can tell, it's a different shirt, it's a different day. It was just too hot that day. And in the meantime, I've been doing some work with the 3D printer. This entire project is based around using that 3D printer to do all of these experiments. So it wouldn't make any sense to carry on with the video until we touch base on what's been going on with that. So here's my office / guest bedroom where I've been working with my new 3D printer. This is the Bambu Labs P1S, and the reason I chose this one was I didn't really want a new hobby. 10 years ago, friends with 3D printers, it seemed like the 3D printer itself was the hobby, trying to get it to run, getting everything dialed in and set up. I just wanted a solution to a problem, and it came down to Prusa or Bambu Labs. Those were sort of the two things based on Reddit and YouTube. That seems to be a printer that just works. It's really well dialed. I bought this one specifically because it has an enclosure, so it kind of looks like a little microwave oven or something, and that allows me to print in a variety of filaments other than just PLA, which is the most common 3D printing filament. I can actually print with nylon, polycarbonate, some pretty cool stuff. And even PLA, it's normally, you don't have a special enclosure to hold your filaments or an enclosure down here. It just sort of sits there in the open, but it can get wet. And it's not very wet, like an entire spool sitting in the humidity might gain 1 or 2 grams, but that moisture affects the quality of your 3D printing. This AMS module, it comes with desiccant inside, just sort of a little silica stuff, and over time, enough moisture gets in, I was having some trouble with the filament I had, and a little stringing, and I was getting some trouble with that. So you got to keep your filament dry. Right now, it's about 71% humidity in this room. It's very, very humid. So this is probably not a problem with a 3D printer in Calgary, where I'm originally from. Inside this box, the humidity is 16%. So I've got a whole bunch of desiccant in there, and that should keep things good and happy. You can also get filament dryers. But for the most part, this thing has been incredible. The unboxing experience was awesome. You open the box, there's a QR code you scan, and it just shows you take everything apart in this order. There's little numbered tabs on everything. It was really, really probably the best unboxing experience I've ever had. Pulling this out and the way it was packaged, it was like, this is a really well thought out machine, to the point where if I bought one of these for my 70-year-old parents back in Calgary and said, hey, can you set this up in your office and print stuff for me back in Calgary? I trust they could actually do it. It's literally just like setting up a printer, typing words and making pages come out, except that the pages are in 3 dimensions. So really happy with this overall experience, except for the fact that my filament was getting wet, and that led to a bit of an adventure for a couple days. And that adventure involves these little guys. So you can go on the internet and there's basically these libraries where you can download 3D print files for free. And this was designed to be filled with little silica beads. It's got a little lid that slides in off the top, and it fits in between these spools up at the front here. Now, the only issue with this is that at my local Bunnings, you get this damp-free stuff, which is actually a calcium carbonate instead of silica beads. The silica beads can be refreshed in an oven, I later found out, but this is apparently much more effective in terms of how much of its weight it can absorb in moisture. This was like 16 bucks Australian, and I picked some up and I figured I'd pour some of it into this and printed this out. And then I realized that stuff is gonna fall out of all the holes, and the way it actually works is it comes like, you stick it in a closet or something to absorb moisture. It's basically like a little yogurt container with a little mesh cage inside, and then you fill it up. And when this gets wet, it actually turns into a liquid, and it like dissolves into the humidity in the air and then drips down into that cage. That would leave a mess if I did this. So what I did is I ended up creating my own little container here. So it's copying the same dimensions, and you set it in there, but mine is nice and waterproof. I've got a bunch of holes in the front that are all at a 45-degree angle, so any moisture would drip into the cage. And then there's a little thing that sits off the bottom like that so that any moisture can form in the bottom of all of this desiccant. And that was, of course, a process where I had to measure this all out, 3D print it, do a few iterations until I got it to fit nicely. And now, in some different colors here, some of my iterations, I've got these boxes full of this calcium carbonate. So now that that's dealt with, I don't have to worry about the 3D printer. It's just working nicely. And if this was set up in Calgary, you'd never have to worry about that. You just put the little desiccant packs in here and you're good to go. But that's the sort of distraction that ends up taking a bunch of time. And of course, the biggest time suck right now is you fill this with silica beads and you stick it inside these spools. You stick it in the middle of the spools. So I got some of those, and it's really cool, the stuff you can make out of this thing. But I'd like to just talk about my 3D printing journey so far. And yeah, step one, picked this one, happy with it. Step two, how do you make things? So you go on the internet, and this was like the day after I bought it. You go on the internet and you download a file, and then you print the file, and you're like staring in the window. I'm just right here watching this thing printing, like mesmerized for about 5 minutes. And then it was amazing how quickly you go from this is magic to like, cool, I guess that just makes stuff. What's the next step? So I started downloading different things, and like I got a cool little skull pencil container. I just printed it at like a scaled down version just to see what it was like. And eventually you find something cool, like a whistle that really works. I'm not going to blow it, but it's like really loud, and I just 3D printed it. At the end of the day, that gets old pretty quick because you're like, well, I could just go to, a store and I could buy some of these little plastic trinkets. What really makes it real is when you need a specific item, like the tray that I made, and then you design it on the computer and it turns into reality. So I went onto YouTube and I decided, okay, let's learn about 3D modeling programs. There's a lot of them out there, advantages and disadvantages. I ended up going with Fusion 360. Seems like an offshoot of some sort of an AutoCAD thing. And it seems like it's a very capable software, but it's also a bit complex. So normally the way I like to learn is I like to just learn the one thing I need to know. So how do I make a circle and then extrude the circle? This is the very first thing that I actually designed and printed. I made a circle, I extruded the circle, and I got this little puck, and I hit print, and then it printed. And that was like this sort of moment of connection in my brain where it's like I can make something on the computer and then it shows up in reality. But this is pretty basic. So rather than just going and learning a specific thing about this program and then trying to get through, I was just lost. It was too complicated. So I found a YouTube course called Learn Fusion 360 in 30 Days. Free course. And I would go through and you watch the video, which is about 10 or 15 minutes long. I just watched it. Then I open up my Fusion 360, hit start on the video again, and then pause the video, do what they're doing in the video, and then start the video again, and then pause and do, and then scratch my head a little, and I missed something, go back. So it took me like 2 or 3 hours to get through the very first video, and I've gotten a little bit better since. But I'm still working through that Fusion 360 in 30 Days course. It's been very helpful to give me a general understanding of what's going on. And now I'm at the point where I still have a lot to learn, but I can actually, when I see something like this, I take my caliper, I can measure it, I can put the dimensions in, and I can sort of copy the shape of this and then modify it into what I want to actually build. So yeah, now that I've been learning Fusion 360 and I can actually make real things, the next step is, okay, well, what am I actually going to build for this pump testing thing? You've all seen these little impellers I've been making. I'm basically going to stick these onto an existing bilge pump, try to size them appropriately to get a little less flow, but more pressure so that the wattage is the same, and see if I can hook this up to an electric dredge. And there's a whole bunch of stuff that I want to learn. So to do that, I need to create my little science station. Here we are. So I was about to take that tote in the basement, the underhouse area, right there. I'm pointing where that tote is. But what I was going to do is I was going to take a nozzle, a couple different nozzles here, and I was going to spray the nozzle into the bucket, time how long it takes to fill, do the math, and that's my flow rate. I'm still going to do that to calibrate this thing, but what this does is this actually measures the flow. I bought a 2-inch diameter version so that when I get like a 2-inch dredge, I can still measure what the dredge is doing. But what this is it's a tube. It's designed for measuring diesel fuel flow, I believe. And there's just a little propeller that spins around inside. I have no idea if this is going to show up on camera very well. You see the thing spinning around in there. But that spins, and one of the blades has a piece of metal in it, and then this is a Hall sensor that senses every time that, I don't know, it's magnet or metal, every time that goes past, it senses it, and then it reads this off on a screen. So in order to hook this up to my bilge pump, the bilge pump runs on a 28 millimeter tube, and I made this little guy right here. There's a tube that comes off the side, and then it goes in and it bends, so it's like in the direction of the flow, kind of like a pitot tube on an airplane. And that's how I'm going to get my pressure readings. So I'll get the pump set up to this. That'll measure the pressure on a pressure gauge. And then it's going to have to flow through this, which is where I designed this guy. So figuring out how threads work was an adventure in and of itself. There's a little direction arrow. These threads, they're NPT threads, and Fusion 360 can put threads, like you design like the shape of something and then you just click here and say add these threads and tell it what to do, and it'll make the threads, but it can't do these threads. So that was another full day of sort of frustration trying to learn how to do this. There's a catalog from McMaster Carr that makes all these ABS fittings and stuff. You go there through Fusion 360, download a part. So this was originally a threaded ABS fitting. So I took that and then I sliced a plane across it and deleted everything and then built my own piece here. So the bilge pump hose is going to plug in here, and then it nice and smoothly comes up to the 2-inch diameter. And make sure I put this in the right direction, not that it really matters. And it just threads right on. So I printed this thing, it threads right on. It's super strong. You can add more or less wall thickness, and you can make these things like extremely strong, but it doesn't need to be that strong. So here, water is going to come in. I'm not sure if I'm supposed to let this get wet, so this will be just up above the surface of the water, and then it's going to pour out this end, and that's what I'm building right now, is a little piece. If this just poured out the end and it was a low flow, the water would be like a river that only fills halfway up. So I made sure that it sort of turns up at the end so that it's always fully submersed in water and just sort of flows out the top there. You'll see that once we get back down underneath the house. But I was able to just, this is what I want, and I created it and hit print and it made it. And that's really starting to set in as like, this is a real solution to creating things. I know it's not, you know, people know about this, but as a new to 3D printing guy, this type of thing that you can do is just fascinating to me. What else can I say? So yeah, I've got the 3D printer running right now. I might as well give you guys a quick B-roll of it printing that next piece. But from here on out, I'm going to be under the house trying to set up everything so I can measure the pressure, measure the flow, and then I can create a pump chart. And that's kind of the goals. Create a pump chart for the stock bilge pump, put it all on Excel and have like a little, like this is what it does, this flow at this pressure, this flow at that pressure, figure it all out, swap out one of my impellers and do the same thing. And that way I'm not subjectively being like, yeah, this impeller is a little better or a little worse. What's it look like? I can actually get real data so that I'm not biased behind, you know, the design. That's when it's going to get interesting. Do 3 blades work better or 4 blades? Which diameter? Like all the different pump things. In order to properly test that real world, I need the test setup, which is under the house. Let's have a quick look at this because it's kind of fascinating to watch. It's going around and it's making something exist that was not there before. There's threads down at the bottom there, and this is going to be the outlet, and it's sort of going to turn over. I'll actually show you on the computer what that is. Should probably have this turned on already. But yeah, basically, if we get this up and running, you can see what's printing. So this is the Bamboo Studio, and you can kind of like left click and sort of look at the piece, and that's what it is. So this is what's gonna thread on, and then this will be facing up so that like it's, you know, a cup up so the water can sort of pour over the edge like that. And that'll keep a completely immersed flow of water around that impeller at all times. And yeah, I obviously I need to calibrate I'm assuming this is gonna work, but I'm still gonna fill up a bucket and time how long it takes to fill that bucket. And then I have a actual tested this much volume in this much time. And I'll use that to calibrate, is this actually working, or do I need to go up or down 5% or whatever it is? But I think that's a good start. One final thing, because I am gonna need a few more days to actually get everything set up, but I got these pressure gauges. Let me just pop you back on a tripod real quick and I'll show you the final thing. So I've got a pressure gauge and a vacuum gauge. So this vacuum gauge will be really cool when I get into the actual dredge testing. How much vacuum can I create? But this pressure gauge, it was the lowest pressured one, like that seemed practical. So it's up to 30 PSI. And this is an NPT fitting. Of course, I couldn't make these threads because they're sort of like tapered and a very specific thread. And that's where the McMaster car catalog came in. I was able to find this piece right here, and I just printed it. You can, when you're doing a small item like this with finer threads, you can change the resolution of your 3D printer. So each layer is thinner and then the threads are a higher quality. So I tested regular and high quality. They both work quite nicely. And this screws right onto that. It fits really good and snug. And then I've got a little nylon hose that can come off and go to this pressure gauge. And that's how I'm going to be reading the pressure with a printed part. I know, oh, it's plastic, it can't be that strong. Honestly, I couldn't tear this apart with my hands. So when you consider if I'm able to pull on this little nipple here with like 10 pounds of force, that's not anywhere close to a square inch. So you could probably put 100 PSI through this and it would actually work. But yeah, it's really cool just being able to make things out of plastic. Got a pressure gauge, a vacuum gauge, the flow meter, and we'll see how long this video is, but it'll be next week. We're gonna get into testing impellers scientifically in a tub under the house, which will eventually lead into testing venturis for a 2-inch dredge or an 1.5 inch dredge, whatever it works out to, which will eventually lead into whatever this is leading into. But that's the process so far. I just wanted to touch base. I know I haven't, we'll see if this video even comes out on time, but we'll see you in the next video. I'll have this set up a little bit better in the basement, and I'm excited to see what we learn. Cheers.